Okay, guys. Air condition. This is an example. This is an example of the typical split unit. Look, the condenser with the compressor is located on the bilge, on the engine room. And in the cabin, in the closet, you have the evaporator. Yes or no? The condenser unit is composed by the compressor, the coil of the condenser, and look, it's composed by. Hey guys, follow me. The condenser unit is composed by the compressor, the coil to cool the refrigerant in the compressor, the condenser, and normally here is the control box with the electrical portion here. That's control box. The control box with the board where the power is coming in, the capacitor, and the circuit board. That's okay? That one normally in a split unit is located close to the condenser. And the evaporator, thank you, the evaporator is located on the cabin. And close to the evaporator you have
The thermostat.
the thermostat. And the thermostat is the element that sends the signal to activate the complete system, the whole system together. Ready, my friend? Okay. The evaporator is composed for two elements. The evaporator unit, the evaporator coil or indoor coil, and the blower, electric blower. The blower suctions the air here, that's the filter. The air, ambient air, pass through the frozen pipes, and you receive here cold air. Yes or no, Roqueta? This is the evaporator. When the ambient air pass through the frozen pipes, some water around the pipes is condensated and drops for gravity in this pan. Some water here is condensated here because those pipes are frozen. When the air is suctioned here, the air enters over there, ambient air, and in the other side, because those pipes are frozen, you receive cold air. That water condensated is what type of water?
Fresh.
It's fresh water, no? And that fresh water is going here out. That fresh water is not going at high speed. It's a little, no? What is this?
Water. Trap.
P-trap. Yeah, it's water. And the water produces a seal to avoid what?
Water going back forward. Gas.
Those outlets will be close to the exhaust outlet of the generator or exhaust pipe of the engines. That P-trap in water avoids that the gases enter here in the compartment. Where is located that unit in the typical small and medium boats?
Bedroom, the cabin.
Behind of the bed,
Under the bed.
in that corner. What happens if gases, carbon monoxide, are entering here constantly because the exhaust pipe of the generator is pretty close?
You die in your sleep.
You get sleepy.
Finito. Finito. Everybody follow me? What is the name of that element?
P-trap.
It's a P-trap. Where is located?
By the outlet.
Is the drain of the evaporator unit. Is the drain of the evaporator unit. And drain fresh water, no salt water. Okay. In the condenser, we have salt water entering, pass through the coil of the condenser, reduce the temperature of the pipe, and goes out salt water.
The out port is usually the port that you see in front of the boat. That's always draining, like that goes
Yeah,
on in
normally it's not necessary in front of the boat, any side of the boat. the boat is connected to the shore power, and you see the water constantly coming out.
Yeah, that one.
That is that water.
Okay.
It's salt water. If you touch that salt water, it's warm, a little hot.
Like in the yachts, it comes out like you'll see them on both sides in the front.
Yeah,
and then the
yeah,
back.
yeah.
I always wondered where all that water.
It's because in that boat they have 4 condenser units, 2 in front, 2 in the back. No, for different rooms.
I always thought it was bilge. I was like, damn, there.
No. It's not a bilge water. Bilge water in some boats, this one could be sent directly into the bilge and with the bilge pump it. If the boat is a sailboat, wooden sailboat, is not recommended. It's better outboard. It's okay, guys?
It sucks water in.
It's clear? This one is salt water from the condenser unit. And this is the water that you see in the boats, in the marinas, going out constantly. It's because the air conditioner is running. The air conditioner is running. If the air conditioner is running, the raw water pump, look, that raw water pump should be running constantly. Okay? You remember yesterday in the diagram of the refrigeration cycle, what happens if this raw water pump is broken?
Yeah, overheats.
Can you explain to me? Yesterday I explained in the refrigeration cycle what happens if that pump is
The high
broken.
pressure switch activates.
Okay, the temperature in the coil of the condenser increase. In the condenser is flowing high pressure refrigerant. You remember? High pressure refrigerant. If the temperature of that pipe increase,
Switch.
the thermal switch located, the high pressure switch located in the high pressure pipes open and interrupt the current in the compressor, and the compressor stops. Anybody follow me? That's the function. Okay. What is the complaint when you have lack of raw water? The customer say, the air conditioner is running. I touch the compressor and the compressor is running. The blower of the evaporator is running, but the air is not cold. It's a little warm. Question number 1. Hey, my friend, you see water coming out through your boat on the side? Yes, but it's a little. It's not like regular. It's a little less. Okay. You have a lack of flow of raw water around those pipes. Then the pressure and the temperature of the refrigerant before the expansion valve is higher. After that, the pipes are not frozen, are cold but not frozen. When the ambient air passes through those pipes, you receive no cold air, a little warm. You understand? It's because you have lack of raw water in the condenser coil. Where is located the condenser coil? Outside. Where is located the evaporator coil? Inside. What is the function of the evaporator coil? What is the function of the evaporator coil?
To freeze and cool the ambient air.
Absorb heat from the ambient air, reduce the temperature. That's the function. No? What is the function of the condenser coil? Release heat. Is clear or not, guys? Yeah? Good? Pay attention. What happens if this filter, where is located the filter that you replace periodically in your home?
Evaporator.
It's here, no? It's here. It's that one. No? What happens if the air filter is completely clogged?
Then you won't get any air. And then you see a big ice.
You don't have enough amount of air passing through the frozen pipes. And what happens?
Freeze up.
Ice block, and suddenly the unit shuts down.
And you see a lot of water come out.
Correct. Or no water because it's block of ice. It's clear, my friend? Periodically, you need remove the filter, apply a special spray to clean the coil, the radiator, and spray water at high pressure in this coil, in your boat and in your home. Once per year, try to do that service in your home. Spray the cleaner and water at pressure. And after that air, now the serpentine is clean, is free, and the air flow over there. Good? And you receive good air in the grill, in the discharge grill. Anybody follow me? Yes or not? Okay. Any other question about that picture?
So if you had a lack of airflow, so if you had airflow but not as much as you should, it's because that coil is dirty.
It's because the coil is clogged. Dirt. Or the air filter. Oh, look at that air filter. That's the problem.
So I have a problem in my house. Air filter is clean, but I looked yesterday and it's all clogged.
Correct.
So I gotta clean it.
Correct. That's the consequence. In your car, you never replace the
The filter.
filter on the evaporator. Where is located?
Behind your glove compartment.
Exactly. In the compartment where
Glove box?
yeah,
Cabin air filter? Cabin air
the cabin air filter. You need to replace that filter periodically. Yeah, Papa?
$10.
What kind of what? Oh yeah, I don't remember exactly the name. It's an indoor coil spray cleaner. You buy in a Home Depot. You found it. That spray to clean those coils. That's important, no? And also in this coil, you remember that coil? This one. This coil, I cut it. Is this, my friends? Is this? Look, the salt water enters here, circulate over there, and goes out here. Look, in the middle pipe you have refrigerant. In the outer pipe you have salt water. In between both pipes you have salt water. If the air conditioning unit is not used frequently, the salt water in between both pipes create calcium and reduce the heat transfer in between both pipes. For that reason, periodically, once per year, you need flush this one with water and bleach, for example, or water and other product that is special to remove that calcium in that area. Once per year. You need to do service in the outdoor coil or condenser coil, and you need to service in the indoor coil or evaporator coil. Right? Both coils. In this coil is where the air filter is located. In that coil, this is the condenser coil, is located outside. You need to pass water with bleach to clean in between both of them.
So in the trucks, when the switch would go bad to turn on the radiator fans, you could unplug those and they keep the fans on. So like when you have overheating problems because the switch goes bad.
Correct.
Is there a way to overdrive this in a boat too, where if the pump goes bad, you can overdrive the pump so it
No,
keeps the water flowing?
no, it's different. It's different. You hear the explanation of him?
'Cause I know when you're changing out a impeller and you don't turn the valve off, you're gonna have a continuous water. So I didn't know if you would still have a little bit of water going through that AC, or if it wanted because it's too vertical.
No. Pay attention. Look at this. Is possible? It's a great question. It's possible that the salt water be mixed with the refrigerant?
Only if it's broken.
It's possible if those pipes are cracked internally. But this is not common because the quality of the material is a copper nickel alloy, you remember? It's a 9010. It's a great alloy. It's practically zero the possibility that those pipes are cracked and the salt water penetrate the coolant. If I have moisture in the refrigerant, it's because what?
Leak.
It's because I have leaks, and normally those leaks are on the fittings. On the fittings where you connect, you remember yesterday the high pressure and the low pressure. In the moment that you insert the fitting, you hear and until you tight the fitting. In that moment that some refrigerant is going out, some humidity is going in. That's not good.
What if it's under pressure and it's blowing out? How
Yeah.
is air supposed to get back?
But let me explain something. When the air conditioning unit was off for a long period of time, the pressure of the refrigerant inside is low. It's low. No, if you try to connect the fitting after you stop the air conditioning unit, the pressure in the refrigerant internally is ultra high, no? And it's not possible that the air penetrate. But if the unit was abandoned for 6 months and you try to connect the fittings, you introduce air, 100% sure, because the pressure goes down, no? And the pressure is stabilized. Everybody follow me? Pay attention. Some people say, why I cannot replace that dryer? Because that dryer absorbs a lot of humidity. Why is sealed? Why you need cut the pipe here, install the new one, solder in the pipe? This is complicated.
No, like the whole line. Like if you had a system that had a lot of humidity in it, wouldn't you need to replace that line too? Because
No.
the dryer will be overwhelmed.
No, the procedure to eliminate the amount of humidity is with the vacuum pump. The vacuum pump absorbs all the humidity, included the humidity in the hygroscopic substance.
Okay.
And it's with this pump. It's with this pump. It's with this pump. I'm going to explain the process. In the videos I have that explanation in detail. And you operate that pump until the gauge reads around 500 microns. This is the moment where all the humidity was absorbed. You stop the pump and you connect the recovery machine and you recharge the system with the Freon again. It's not complicated, it's simple. I'm going to explain how to use the vacuum pump, how to connect the vacuum gauge, and the vacuum gauge normally starts in 2000 microns. But working, and 10 minutes later is 1800. 45 minutes later is 1100, yeah? 1.5 hours later is 600. 10 minutes more is 400, yeah? When it's around 500, 400 microns, the system is considered with zero humidity. And in that moment, you stop the pump and you can recharge the refrigerant, new one, fresh refrigerant. I don't recommend recharge the system with the used refrigerant, because the used refrigerant have moisture, no? With fresh refrigerant, you recharge the system because you do the vacuum according with this, and now you are ready. In the video, I did the vacuum for one unit here, and I recharged the system.
What happens if you go below 400? Like if you go to zero, what happens?
You never reach zero. You never reach zero. When you arrive around 350, 380, the machine stay over there. Doesn't matter if you operate 5 hours more. Never decrease.
It doesn't hurt the system.
Yeah. No problem. No problem. It's better. It's better. Yeah, Papa. Dr. Tacho. Good.
Yeah, I was just making sure that you said more microns.
More microns, more humidity.
More humidity.
Yeah. If you have 2000 microns here, you have a lot of humidity. When the the pump start to work, the micron will be reducing around 500.
Okay.
When it's around 500, you can disconnect the pump.
All right, so
That's the pump. That's the pump. My friend, I recommend in this class, check the videos, because I spend a lot of time doing the videos with too much details. I connect this, and I wait until the vacuum was complete. I show in the camera when the number decrease until 500. I disconnect, and after that I connect the recovery tank and charge the system. Check the videos. I appreciate that you check the videos. It's good for you. I am going to follow again the path of the refrigerant. Okay, guys, look at the path of the refrigerant. The refrigerant enter blue color, you see, at low pressure in the input feeding. The compressor compress the refrigerant. In the output feeding, red color is going out, and it's going out here. Compress it at high pressure and high temperature. This line will be, when you touch the line, will be hot. pass through the filter and dryer, reduce the temperature. After that, the diameter is reduced. What happened and the goes down. And what happened with those pipes?
Cold.
Practically frozen, no? And the refrigerant continue and enter in the bottom of the evaporator. The refrigerant here is liquid. In the other side, a couple of inches later, start to evaporate, but used in the output is liquid with low pressure, low temperature, but it's liquid, and start to evaporate basically at the bottom of the evaporator.
Are the lines a specific length to allow to make sure that it's
Yeah, the length and the diameter is specific. It's calculated according with the capacity of the evaporator and the capacity of the compressor. Pay attention, my friends. In the bottom of the evaporator, the refrigerant enter and start to evaporate. Oh, the warm air, because I have the ambient air of this room, help in that process to evaporate the refrigerant. No? When the refrigerant goes out here, it's completely evaporated. It's evaporated, but if you touch those pipes, are too cold. Not frozen, but too cold. And the refrigerant is boiling because it's with the pipes are surrounded for ambient air. You remember? And the refrigerant normally is boiling at -2 degrees. Oh, right now at this ambient temperature, it's boiling. Okay, it's boiling, but it's boiling for him. But for you and me, when you touch those pipes, are too cold. Okay, it's completely vapor, and return here and enter in the compressor vapor. And once again is compressed, and once again is sent out. This is the cycle. Okay, look. This is a small, until this point, and after that increase again. Increase again, and at this diameter.
Okay.
Yeah.
And that's the same diameter on the inside of the evaporator?
Yeah. But in this section, the pressure and the temperature was reduced. The pressure and the temperature never increase again. No, only the refrigerant start to boil. And it's good bigger diameter because boils better.